For most people, working with Unix these days means working with Linux. As I record this, Linux just entered its 30th year of existence, and the Linux kernel has accepted its 1 millionth commit. Linus Torvalds is a talented and productive individual, but those kinds of numbers could only happen with the help of thousands of other talented and productive individuals. When it comes to software security and reliability, there's just no replacement for all those sharp eyes carefully watching the code decade after decade. For me at least, the first word that comes to my mind when I think about the Linux kernel is mature. And as we've seen through this course, Linux is heir to all the finest features and traditions originally introduced by Unix. Still, as we've already noted, we're here learning about Unix in general because it's an important part of the history of the Linux kernel. And here's where we'll actually get to see those traces of Unix DNA in the kernel itself. Here, if you're about to build your own version of the Linux kernel, is where you'd actually apply your Unix knowledge. Through the rest of this module, I'm going to show you how to build your own kernel or distribution. Since this is a big picture course, we won't go deeply into the command line and see the process through to its bitter end, but we will get a bit of a feel for how it happens. To see how it really works, check out Andrew Mallett's Linux kernel and system startup course here on Pluralsight. Andrew will make sure you're completely taken care of. But for now, we'll begin with the kernel itself. You can't modify and customize a kernel until you get access to it. I'm not sure it's a great idea, or even possible, to edit the kernel on a running system. So the trick is to download a brand new, fresh copy. You do that from the website kernel.org. Here's where you'll find various package types for the most recent few mainline, stable, and long-term release kernel versions. Both newer and older versions are available through HTTP using programs like wget, and of course, you can clone a kernel version using Git. And if no one's looking and you don't mind doing things the uncool way, you could just click that big yellow button and download it directly. Once the kernel is downloaded and unpacked, it's time to take a look around. See this documentation directory? It's packed full of files and directories containing loads of helpful advice, context, and warnings about the task you're about to begin. There are, in fact, so many of those documents that you really don't have much of a hope of getting much out of it in its raw format. And that's especially true considering that some of the files use the restructured text markup notation. So feel free to compile the content into an HTML-based documentation site. When you're all done, including quickly setting up, say, an Apache web server that exposes your archive to clients, you'll be able to point your browser to the IP address used by your build server and you'll have the whole works at your fingertips. Or if that doesn't appeal to you, just visit the public version at kernel.org/doc/html/latest. Let's take a small step backwards. Why might you want to compile your own Linux kernel? Well, perhaps you're planning to manufacture an Internet of Things device, and the kernel will be embedded on a really small hardware platform with limited storage space and only a few hundred megabytes of RAM. Modern Linux kernels come with compatibility with all kinds of hardware peripherals out of the box. But you're not going to be using more than a couple of very lightweight add-ons with your deployment. So you might as well remove all that software you just won't be needing. Now let's take a look inside the drivers directory. There are 140 different objects there, mostly subdirectories, which means that there's an awful lot of software running that's begging to be removed. How likely is it that our Internet of Things device will need a CD-ROM driver? Does your new laptop even have a CD-ROM drive? What's in that cd-rom.c file? As you can probably guess, it's in C language. As you can see, there are lots of useful comments. In fact, Unix and Linux are known for great documentation, so you can pretty much expect this level of service. As you can see, the driver goes all the way back to 1996. However, the to-do list section suggests they're not quite finished yet. I wouldn't worry about that though. The point is that you're able to edit the file, and as a result, the way the kernel will behave with CD-ROM drives once you compile the new edition. But you're also able to simply remove the CD-ROM directory along with any others you won't be needing. It's really that simple. The actual act of compiling a new kernel can be as simple as running this single command. Of course, in the real world, it's never that simple. For one thing, you'll have to first install all the packages necessary for a build environment, not to mention account for package dependencies that are different from the ones used by whichever how-to guide you're using. But once you do successfully compile your kernel, You just need to install the Linux headers files that the operation outputted onto your target machine, or perhaps on the SD card you'll be using to boot your Raspberry Pi Internet of Things device, and then reboot. I'm obviously leaving out a bunch of other important steps here too, but it is just software, nothing magical. To confirm whether the whole thing worked, you can run uname-r on your machine after rebooting, and it'll show you the kernel version that's currently loaded. Find this useful? Why not follow the link in the description and head over to view the complete course on Pluralsight. And of course, for even more technology goodness, don't forget to subscribe to this channel.